Dear student, today we discuss about the Fourier series, and related to that Fourier series, we consider here the Parseval's identity of the Fourier series. In our the previous lectures, we just complete what's with the Fourier series, full range Fourier series, half range Fourier series, sine series, and cosine series. Both we consider calculated in our previous classes. Now, today we discuss about the Parseval's identity regarding the Fourier series. And Parseval's identity is nothing but the one kind of things that sometimes it's required to prove one equality of both sides. So for that cases, the Fourier series says that if considered for the case of the full range series minus t2 plus t on that cases, and this is our the Fourier series, full range Fourier series. As you know, a0, an and bn are the Fourier coefficients. With respect to that Fourier coefficients, here is the one equality. This is known as that the Parseval's identity for the Fourier series, full range series. And similarly, for the cosine series, as we know, for the cosine series there are the two Fourier coefficients required, a0 and an, and regarding with that a0 and an, here it is the Parseval's identity for half range Fourier cosine series. And last one, number 3, half range Fourier sine series. This is the sine series, and here only the coefficient is that the bn. And regarding that coefficients bn, it's 2 by t, and this will be the half range Fourier sine series, the Parseval's identity. And with that, the Parseval's identity, we just consider some examples, and regarding that examples, we prove some equality. For that case, first we consider here the example number 1, first examples. This is the Fourier series. Looking upon here the example. What is the example here? Using Parseval's identity for the Fourier series, for this function, prove this equality. So for that case, looking upon here, what is the range is given? The range it is given minus pi to plus pi. That means here the Parseval's identity for full range series. And for the full range series, what will be the Fourier coefficients? As we do, these are the formula, general formula for the Fourier coefficients. A0 1 by pi minus pi to pi fx dx, and its value will be the pi. We do not calculate here because in the previous lectures already we explained how we have to find out the Fourier coefficient a0, an and bn. So on that process we can easily find what is the value of the Fourier coefficients. Here an and bn also consider here this value. So next question is that what is the Parseval's identity? Parseval's identity for Fourier series, full range series, this is the general formula. So now we have to put here the general formula, and what is the value? Here the range is minus pi to plus pi. So if I put here the value, it will be 1 by pi x, pi by 2 minus x whole square dx, and right hand side a0 square by 2, a0 means pi, pi square by 2, a0 means pi, this one, plus summation an square plus bn square. An means 0, 0 square, plus bn means minus 1 to the power n, 2 by n, its whole square. So minus 1 to the power n, so always it will be the positive, and 2 by n, its square means 4 by n square. 4 by n square, this is the one. Now we have to calculate the left hand side. What will be the value of the integration? The value of the integration, when we calculate it, 1 by pi, its value, it's a whole square, that means pi square by 4 x minus 2ab, 2 cancel pi x plus x square, this one, x square by 2, and this is the integration x cube by 3, this one, and minus pi to plus pi. Just I consider together here pi square by 4 integration, and this is the x. Here it will be x square by 2, this one. And the right hand side, what it was, the same thing on the right hand side, and the left hand side it will be just we put the value limit, this one. Here it will be pi square by 4. Here this is the 2 pi, this one, minus its value will be the 0, and plus here its value will be 2 pi cube by 3, this one, and right hand side what it is. And next the calculations, here it will be 2 cancel 2, that means 1 by pi, here pi cube by 2 plus 2 pi cube by 3, and right hand side is what is the same thing. And left hand side, here it will be the 1 by pi, calculation 7 pi cube by 6, this one, and right hand side this is the same what it was. Now we calculate, consider here again. So left hand side here the 1 by pi, this pi cancel हो जाएगा, that means left hand side 7 pi square by 6, 7 pi square by 6, minus from the right hand side pi square by 2, and right hand side summation 4 by n square. This calculation we consider 7 minus 3, 4 pi square by 6, that's equal to summation 4 by n square. And this 4 cancel, and it will be, that is summation 1 by n square, that's equal to pi square by 6. So looking upon here, summation 1 by n square, that's equal to pi square by 6. This one, this is our result, and this is the from Fourier series, full range Fourier series. We can say that this will be our the result. Easily we can prove it. Now we consider the second another one problem. So consider here example number 2. Here this is the Parseval identity for half range Fourier sine series के लिए, for sine series. Here the function is if x equal to pi minus x is the function and interval is 0 to pi. So looking upon here for half range series, sine series, and what will be the Fourier coefficients for the half range series? It's required only the bn, and the value of the bn is this one. What actually we calculated in our the previous class also. How to find out this one? Just find the value of the integration of this one. You can get the result. Now this is the Parseval's identity for Fourier sine series. So now put here Parseval's identity, this one 2 by pi 0 to pi function whole square, and right hand side bn square. So left hand side calculations, if we consider here 2 by pi and integration pi minus x whole cube by minus 3, integration of this one, and 0 to pi, and right hand side summation bn square. Bn means 2 by n, that is 4 by n square, this one. So now if we put here the limit, so 2 by pi, yes, upper limit के लिए its value 0 हो जाएगा, lower limit के लिए minus, that means pi cube by 3. This is only for the lower limit, and right hand side that will be equal to summation 4 by n square, this one. Obviously here always it will be n1 to infinity, 1 to infinity, n1 to infinity. So that means 2 pi square by 3, that is equal to summation in 1 to infinity 4 by n square. This one. So nextly, here is the left hand side 2 and here is the 4, that means cancel, it will be the 2. That means pi square by 3, that's equal to summation in 1 to infinity 2 by n square. This is nothing but pi square by 6, pi square by 6, that's equal to summation in 1 to infinity 1 by n square. Proved. So this is also another one thing, that means you have to given this function by using the Parseval's identity. We have to prove this one. So this is all. So for that type of cases, exactly we have to remember what is here the Fourier coefficient. Find the Fourier coefficient and put on this equality, this one. Then you can easily find out. Now we consider another one examples. Example number 3. Here, by using Parseval's identity for the Fourier cosine series for the function fx equal to x square interval 0 to pi, and we have to prove this one. For proof of this one, looking upon here the function fx equal to x square 0 to pi half range series cosine series. So obviously for the cosine series we know it's required a0 and an, two Fourier coefficients required. One is a0, another one is an. And the value of the a0 2 by pi 0 to pi fx dx. Its value is this one, and this is the calculations only. Just you can find out this by using the integrations only. And similarly, an its value will be this one. So for the Fourier Parseval's identity for the cosine series, this is the formula. As we know in the first slide, already provide this with the formula. Just we put here the values. Here the interval 0 to pi, that means here 2 by pi integration 0 to pi fx whole square. Fx means x square whole square means x to the power 4. Here fx equal to x square, so x to the power 4 dx. And right hand side a0 square by 2. A0 square means this is the a0 square. A0 square means 4 pi to the power 4 divided by 9 into 2 plus summation in 1 to infinity an square. An means this one, an square means this one. It will be 16 by n to the power 4. So now we have to calculate the left hand side only the integrations. It is 2 by pi x to the power 5 by 5 integrations the limit 0 to pi this one, and right hand side 4 pi to the power 4 divided by 18 plus summation 16 by n to the power 4. So when we put the limits, its value will be here 2 by pi to the power 5 by 5 and minus 4 pi to the power 4 by 18, that's equal to right hand side 1 to infinity 16 by n to the power 4. So this pi, यहाँ पे pi cancel होगा, यहाँ पे 4, so that means 2 pi to the power 4 and 4, that means 2 pi to the power 4 by 5 minus 4 pi to the power 4 by 18, this is equal to summation 16 by n to the power 4. Now the left hand side the calculations here. 36 minus 20, that means 16 by 16 pi to the power 4 divided by 90 left hand side, that's equal to summation 1 to infinity 16 by n to the power 4. Now just this 16 both sides cancel हो जाएगा and here it will be pi to the power 4 pi to the power 4 by 90. This is equal to summation n 1 to infinity 1 by n to the power 4. So this is n1 to infinity 1 by n to the power 4 equal to pi to the power 4 by 90. This one, and hence. So this is just the Parseval's identity. Another one, that means just applying the Parseval's identity, we can easily prove this type of the series, infinite series, what will be the value of that series. So previously, sometimes when we consider for the convergence cases, sometimes we say that this series will be the convergence or this series is the divergent. But for the case of the convergence, we don't know where it converges. That means what is the value of that summation of this right hand side. So we can easily say that here by the help of the Parseval's identity, it converges to pi to the power 4 by 90. Here, similarly, if we consider the previous one, here this series, here summation 1 by n square, that will be equal to pi square by 6. This one, that means this series, the right hand side, this series converges to pi square by 6, and similarly in this way we can easily say what will be the series and this one. And thank you.